Questions 21 through 25 on the 2007 Grade 10 AMC 10A. A sphere is inscribed in a cube that has a surface area of 24 square meters. A second cube is then inscribed within the sphere. What is the surface area in square meters of the inner cube? So first you've got a cube, and inside you've got this sphere. Now please pretend this is 3D. Now they tell you an interesting thing. They tell you the surface area. Well, if the cube has a side length, let's say x, from here to here, let's say is x, then all the sides are x, correct? Well, the surface area is 6 times the area of one of the sides, which is x squared. And they tell you that's 24. So that means x squared is equal to 4, so x is 2. Now, if you look at this sphere that I have drawn in red, I really just drew a circle, but please pretend that it's a sphere. One thing that we know is that top to bottom for that sphere will be what? It will be x, correct? Because the sphere is inscribed perfectly in this cube. So its very top will touch the top of the cube, and its very bottom will touch the bottom of the cube. So that top to bottom distance is x, equal to x. But what does it represent for the sphere? For the sphere, it represents the diameter, or 2 times the radius. So 2 times the radius of the sphere is basically equal to x. So 2r is equal to 2, because x we just figured out was 2. So therefore r is equal to 1. So the radius of that sphere is 1. So that's the first step of this question. Now the second step is to understand that inside this sphere is another cube. So something like that. You've got this cube now inside of the sphere. And then we have to figure out the surface area of this smaller cube. All right, let's think about this for a second. The first thing I want you to understand is that if you were to draw a line from the very center of this sphere to the diagonal, like that, to meet at a corner of the cube, that represents the radius of that sphere. Okay, so this is the center of the sphere. It's also the center of the cube, and this is the corner of one of the faces of the cube. Now I'm going to draw a line from the center to the exact same kind of scenario, like that, and I want to illustrate that that's also the radius. So I hope you are convinced of that. Done it twice to kind of illustrate the importance of understanding that. Okay, now we get to the heart of the matter. Drop a line from the center down to the bottom right there, and drop a line from that point to the corner, like that. Okay, and that triangle that I just drew is going to help us figure out the length of each side of that cube. So here we go. I'm going to draw that triangle over here, sort of as a flat, like head on. And there we go. So first and foremost, let's label this. This part is r, the hypotenuse. From here to here, though, what is that? Well, if you look at the diagram, this point is the center. So if I drop a line from the center to the base, it really represents half the distance from top to bottom. Correct? So if top to bottom, we need to actually first label, let's call it y, the side length of this smaller cube. Top to bottom is y, this must be y over 2. Like that. Okay? So that's pretty straightforward. Now this guy, which is this guy, That's a little bit more complicated, but it shouldn't be too bad. To calculate that, what I'm going to do is I'm going to draw this base over here, but I'm going to draw it straight on, like flat, if you're looking at it from a bird's eye view. It's essentially a square, so it's going to look like this, right? And that center was right here, and essentially that line is from the center to the edge, like this. This right here represents this right here. Okay, so I hope that makes sense. And then in order to figure that length, I have to draw a line from here to here. Okay, so here we go. This distance is just going to be half of the edge length, so that's y over 2. And similarly, that is also y over 2. So now we can figure out this distance, whatever you want to call it. We can just call it small d. So y over 2 squared plus y over 2 squared is equal to small d squared. So this looks like y squared over 4 plus y squared over 4. So that's 2y squared over 4. And that is equal to d squared. So therefore d is equal to y over root 2. So that's the distance from here to here. And in my diagram, when I wrote it flat like that, that's represented by this line, y over root 2. Okay, we are almost done. Now I just have to use this triangle to figure out the length of y, because I know r is equal to 1. So here we go. Pythagoras, y over 2 squared plus y over root 2 squared is equal to r squared. So this looks like y squared over 4 plus y squared over 2 is equal to r squared. Adding fractions, top and bottom by 2, so that becomes 3y squared over 4 is equal to r squared. And therefore, r is 1, so 1 is equal to 3y squared over 4. Therefore, y squared is equal to 4 over 3. Correct? And now, finally, we get to the very last step, which is the surface area of the smaller cube. Well, surface area is 6 times the area of each side, and the area of each side is y squared. Y squared, we just figured out, was 4 over 3. So there you go. The answer would be 8. So number 21, the answer is 8, which is C. A finite sequence of 3-digit integers has the property that the tens and units digit of each term are respectively the hundreds and tens digit of the next term, and the tens and units digit of the last term are respectively the hundreds and tens digit of the first term. For example, such a sequence might begin with the terms 247, 475, and 756, and end with the term 824. Let S be the sum of all the terms in the sequence. What is the largest prime number that always divides S? So first, let's understand this question. They've given us an example, so let's just use that. 247, 475, 756, and then let's try to understand what they're doing. The tens and units digit of each term respectively, and the hundreds and tens digit of the next term, and the tens and units digit of the last term, and the hundreds and tens digit of the first term. Okay, so we got to think about this here. So basically what they're saying is the following. They're saying that you've got these two numbers, right? 4 and 7. This is the tens digit, and this is the units digit. And those two digits are the same as the hundreds digit and the tens digit of the next term. This is the hundreds digit, and this is the tens digit. So do you see how the 4, 7 appears twice? That's what they mean. That is what this sentence means right here. All right. Now let's interpret the next part. For that, I need to write in the very last term. And the very last term they gave me was 824. So I don't know how many terms there are, but eventually we get to the very last one, which is 824. Let's talk about the next sentence. The tens and units digit of the last term, so that would be these two guys, are the hundreds and tens digit of the first term. These two guys. So you see the 24 appears twice. 24 here is the tens and units digit. 24 here is the hundreds and tens digit. Okay? So I hope that's clear. So what I'm going to do is there's several approaches to this, but I'm going to show both because I want to be complete. The first is just to figure out the numbers and take it from there. Okay, let's see here. Following my rules, looks like 4-7 was here, so then 4-7's here. 7-5 was here, so 7-5 is here. Correct? 5-6 is here, so 5-6 has to go here. Right? And then the third digit, I don't know. And then the next one, the 6 and something, let's call it X, was here, but we've got to shift it to get it here, like that. And then the third digit, I don't know, so I'll call it Y. Got it? And then, in a very similar way, you've got to shift the XY. So if it was there, it's going to be XY is going to be here. And then I introduced the Z because I don't know. But now there's too many unknowns. So what if I said this XYZ is just 824? This is 8, this is 2, and this is 4. Well, if that's the case, then this 6XY is 6, 8, and 2. And therefore this 56X is 5, 6, and 8. This makes sense. This holds true. It meets the requirements of the question stem. 4-7 moved to here, then 7-5 moved to here, then 5-6 moved to here, and then 6-8 moved to here, and then 8-2 moved to here, and then in the end we added this 4. Why? Because this 2-4 has to match with this 2-4. Okay, so we've got a sequence that matches the criteria in the question, so let's add them all up. We have to get S, which is the sum. So S is basically the sum of all these guys, 247 plus 475 and so on. And that sum is equal to 3552. So let's see. Does it divide any of these guys? Does it divide 3? And the answer is yes, it does. Does it divide 7? No. Does it divide 13? No. Does it divide 37? Yes. And does it divide 43? No. All right, so I've narrowed it down to 3 and 37. And of those, the largest is 37. So can I choose D and just move on? Tempting, right? You think, well, perhaps. Now, what I encourage you to do is maybe come up with one other scenario. One other scenario that matches the criteria and see what happens. And I guarantee you that, again, it will be divisible by 3 and 37. So this way is sort of what is known as the, I guess, case way. But the case way, how many cases are you going to do, right? And your hope is that eventually you find one that's going to be able to eliminate either the 3 or this 37, because you have to narrow it down to one answer. But what if none of the cases eliminate 3 or 37? Then you have to sort of take a chance and say, well, the largest of those two is 37, so I'm going to choose 37 and hope that's the right answer. There is a more exact way of doing this question, and it is as follows. It's actually pretty straightforward. And I don't even have to do anything new. I'm just going to concentrate on this guy right here, since I've already made a sequence that works. Let's go with it. Concentrate on the fact that this 4-7 basically moved to become 4-7 the first two digits of the next number, correct? Now, this 2, 4 had to match the first two numbers. So that means there's a 4 here, there's a 4 here, and there's a 4 here. So in any such sequence, you're going to have a digit that appears 3 times. So, for example, in this case, it's 247, and it's 475, and at the very end, there was an 824. So that 4 is going to appear 3 times for sure, or any number, really. It appears in the units digit section, the tens digit, and the hundreds digit. So in terms of a sum, if you just look at the 4s, this gives you a 400, its contribution to the sum. This gives you a 40, that contribution, and this guy gives you a little 4. So in that sum, this all adds up to 4, 4, 4. Correct? And now we have to think, okay, well, 4, 4, 4, what is it divisible by? Well, it is equal to 4 times 1, 1, 1. And the 1, 1, 1 can be further divided into 3 and 37. So these two prime factors are always going to be part of the divisibility of this number. 3 and 37. And the larger of those two is 37. So that's why D is the answer for number 22. How many ordered pairs mn of positive integers with m greater than n have the property that their squares differ by 96? So they're told us that m is greater than n, and they want us to figure out m squared minus n squared. The squares differ by, they're saying 96. All right, so we have to figure out how many pairs satisfy that. Well, this factors pretty nicely. M, n, n, minus plus, and that is equal to 96. All right, well, 96, before I, move forward, let's see, what is 96 in terms of its prime factors? It's 2 to the power of 5 times 3. So that's going to give me 6 plus, let's see here, 6 times 2, 12 factors. All right, so let's make a list of the possible choices of what can be this number and what can be this number, because two numbers multiplied together have to give us 96. All right, so m minus n and m plus n. So here we go. M minus n can be 1, m plus n can be 96. That will work. 2 and 48, that will work. 3 and 32, 4 and 24, 6 and 16, and 8 and 12. That's it. And then after that, you'll get like 12 and 8, 16 and 6, 24, 4, 32, 3, 48, 2, and 96, 1. Now, I wanted to write them out because I want to be complete. But the good news is all of these you don't have to worry about. Why? Because m is greater than n. So if that's the case, then m plus n must be greater than m minus n. And therefore, these guys don't hold that inequality. So we only have to worry about these 6. So the maximum number of possible mn pairs is 6. So that means we can immediately eliminate those two answer choices. So here we go. Let's start with the first one. M minus n is equal to 1 and m plus n is equal to 96. Very quickly, if you add them, you get 2m is equal to 97. And if you do the math here, 97 divided by 2, 48.5. Well, m and n have to be integers, so unfortunately that doesn't give me any solutions, any integer solutions. All right, let's go to the next one. M minus n is 2, m plus n. is equal to 48. So adding this very quickly, you get 2m is equal to 50, and therefore m is equal to 25. Well, m is indeed an integer this time, so very quickly we can get n by substituting back in any of these. And if we do, we get n is equal to 23. So there we go. We've got one integer solution. Let's keep going here. So this is great. This gives us an integer solution. Next one, m minus n is equal to 3. And m plus n is equal to 32. Adding, we get 2m is equal to 35. And therefore, m is equal to 17.5. Unfortunately, that is not an integer. So no solution there. All right. We've got probably just three more. M minus n is equal to 4. M plus n is equal to 24. Therefore, 2m is equal to 28. And m is equal to 14. That is an integer. Solving for n, and that will give you n is equal to 10. There you go. We got another one. So solving again, m minus n is equal to 6. M plus n is equal to 16, this guy right here. And adding, we get 2m is equal to 24, m is equal to 12. And solving for n, we get a value of, sorry, this is not 24, that's 22. So m is 11, and therefore n is 5. So there we go, we got another solution for m and n. And then one last one, m minus n is equal to 8. M plus n is equal to 12. 2m is 20, and therefore m is 10, and therefore n is equal to 2. So we got another one. So 1, 2, 3, 4 ordered pairs that we got that satisfy this, and therefore number 23, the answer is B. Circles centered at A and B each have radius 2 as shown. Point O is the midpoint of AB, and OA is 2 root 2. Segments OC and OD are tangent to the circles centered at A and B respectively, and EF is a common tangent. What is the area of the shaded region ECODF? The first thing I'm going to do is join A to C like that. And I will label this segment from O to C as X. And they tell me in the question that the radius is 2 of the circle. So that means that A to C is 2. They also tell me that OA, that segment, is 2 root 2. So I can label that. And they tell me that this line OC is a tangent to the circle. Therefore, that angle is 90 degrees. So I can use Pythagoras to figure out x. So we've got 2 squared plus x squared is equal to 2 root 2 all squared. That gives me 4 plus x squared is equal to 4 times 2, which is 8. And therefore x squared is equal to 4, and x is equal to 2. So that distance is 2. So therefore, this is an isosceles triangle. That is 2, and that is 2. And if that is the case, then this angle is the same as that angle. Since this is 90 degrees, this must be therefore 45, and that is 45. So that is the first part of the question. Now I want you to understand that there's a lot of symmetry in this diagram. If I draw a line from O straight up like this, and I just concentrate on the left side, it will basically be half of the whole shaded area. So if I just concentrate on this shaded area, and then at the end I double my answer, it will give me the correct answer. So that basically means that the area of the shaded region, AS, divided by 2, which is what I'm going to calculate from this diagram that I'm drawing in red like that. That is what I will concentrate on, and it is equal to the following. First and foremost, it's going to be the rectangle, and that rectangle I'm referring to is right there. This green rectangle. I have to first calculate that, so I'll just draw that here, rectangle. Then I have to subtract from that this quarter circle. All right, so that's the next thing I have to subtract. And finally, I have to subtract a region that is right here, this region in here. And that region I will call S. So minus S. If I can do that, I will get the area of the shaded region. So here we go. First and foremost, let's see. The rectangle is pretty straightforward. It's length times width. The length is from here to here, which is 2 root 2. And the width is from here to here, which is just the radius of the circle, which is 2. So that takes care of the area of the rectangle. The area of the quarter circle is pi r squared all over 4, right? Because you're taking 1/4 of the circle. Now what is r? Well, the radius of the circle is 2. And then now I have to figure out S. S is a little bit tricky, not very tricky, but I'll do it up here. And then I'll plug it in down here. So what is S, first of all? S is represented by the following. It is this region right here. Now, how do I get the value of S? I can do the following. I can take the triangle that is right there, and I can subtract from that triangle this segment of the circle. So I'll draw that over here. First, I will take the triangle, and I will subtract from that the pi segment that is right here. So here we go. Area of the triangle, well, that's just 1/2 base times height. I can use this as the base and that as the height. Both of those distances are 2. So it's 1/2 2 times 2. The pi segment is basically a fraction of the total circle. Well, the total circle is pi r squared, where r is 2. But what fraction? The full length is 360 degrees all the way around. But what is my segment? It's only 45 degrees. So that's what goes in the numerator. So there you go. So this is 4 over 2, which is 2. 45 over 360 is 1 over 8. And then pi times 2 squared is 4 pi. So this S is just 2 minus pi over 2. And that is what goes in this bracket. 2 minus pi over 2. So there we go. We have AS over 2. And then at the end, I'll double it to get AS, area of the shaded region. So this one becomes 4 root 2 minus pi times 2 squared, which is 4. 4 over 4 is just 1, so that's just pi. And then when you take this out of the brackets, it becomes minus 2 plus pi over 2, like that. So this looks like 4 root 2 minus 2 minus pi over 2. And that's AS over 2. And then finally, if you were to multiply through by 2, you get AS is equal to 8 root 2 minus 4 minus pi. 8 root 2 minus 4 minus pi. and that would match choice B. For each positive integer n, let Sn denote the sum of the digits of n. For how many values of n is n plus Sn plus S of Sn equal to 2007? Several approaches to this question, and I'll just go systematically without anything too fancy. First and foremost, what I want to know is how many digits are there in S. That will help me create a certain range, because otherwise there's way too many values for me to look through. I don't think it's 1 digit or 2 digits. Probably got to be at least 3 digits. So what is my largest 3-digit number? It's 999. Let's see if this even comes close. N plus Sn, like this, plus the S of Sn, and that's got to be 2007. Well, n is 999 plus Sn, the sum of the digits of 999, which is 27, plus the sum of the digits now of 27, that's what this means. So that would be 9, and that is equal to 1035. So I fall quite short of 2007. So that means n must be 4 digits. It must be a 4-digit number. Okay? Now, one thing for sure is that n has to be less than 2007, right? Because think about it. If it's 2007, it would be 2007 here, plus the sum of the digits of 2007, which is 9, plus the sum of the digits of this, which is another 9, and that's obviously going to be greater than 2007. It's going to be 2025. So n has to be less than 2007. So my range for n is less than 2007, but greater than 1,000, right? Because it's got to be a 4-digit number. Now that's a very big range, and I certainly don't have time to go through every single value, nor would you want to do that. But I can do a little bit of experimentation and break this down into some cases. And the first is if n is greater than or equal to 2,000, and then I'll look at values that are very close to 2,000 but are less than 2,000, like that. So let's look at this one first. If it's 2,000, and we can do this pretty quickly, 2,000 using this formula right here. 2,000, sum of the digits of 2,000 is 2, and sum of the digits again of that is 2, and that gives me 2004. Okay, not 2007, but it's pretty close. How about if I chose 2001? Sum of the digits of that is 3, sum of the digits of 3 is just 3, and there you go, that is 2007. So I just got one value that works. So it's got to be at least 1, so we got 1. Now, we want to do this quickly, right? It's a math contest. We don't have all day. We've got probably 3 minutes. So in a very quick way, we want to see if this trend is going to continue. 2002 plus 4 plus 4. Ooh, this is going to be way over. Well, not way over, but it's actually 2010. So that's it. For this, we are done. We don't need to look at any more values. All right. Now let's turn our attention to this guy. Less than 2,000. All right, let's do this quickly. 1999. Let's start with that and keep going. Let's see. Sum of the digits 27 plus 1, 28. And then the sum of the digits of 28 is 10. And this looks like it's 2037. Okay, it's not 2007, but that's okay. Now, instead of going down every one, 1998, 1997, that's going to take forever. I'm going to go down by tens. So this one gives me 19 plus 10, and that is 2019. All right, I'm going in the right direction here. I'm getting closer to 2007. Let's go down by 10 again, 1980. This is 18 plus 9, And that is 2007. Look at that. So we got another one. Great. Let's keep going here. Let's try 1970. That gives me 17 plus 8, and that is 1995. Okay, so we've gone lower, so that's it. Now, it's tempting to just say, okay, there's probably only two. Let's choose B and move on, or end. That's the final question on the contest. But the answer choices are actually 2, 3, 4, 5. They're going all the way up to 5. So that makes me think that there might be a couple more. So what I'm going to do is very quickly hover just around 1980. And that's all I'm going to do is just look at the very vicinity of 1980. Because once I get up to 1990, we're going to 2019 and we're getting much bigger. And once I go down to 1970, we're getting smaller. So let's start with 1981. Let's see what we get. This becomes 1 plus 9, 10. 10 plus 9, 19. 19, 9 plus 1 is 10. And that is 2010. Let's try 1982. That is going to be 20 plus 2. And that looks like 2004. Let's try 1983. That looks like 21 plus 3. And that is indeed 2007. So there we go. We just got another one, 1980. And let's go in the other direction, because I don't think this is going to keep helping us if we go greater than 1983. Let's go in the other direction. So 1979, that's going to give me 26 and 8, and that sum is 2013. Let's try 1978. That gives me 10 plus 15, which is 25, and then 25 gives me 7. So 1978 plus 25 plus 7 is 2010. All right, let's try 1977. That gives me 10 plus 14, which is 24. 24, sum of the digits is 6. So 1977 plus 24 plus 6, and that is 2007. Great. So we got another one. And the good news is that those are the only ones. 2001, 1980, 1983, and 1977. And the answer to this question, therefore, is 4.